Hi there. So today I want to walk you through setting up a proximity sensor on my drone and showing you how I plan to integrate this little LiDAR that I bought from LightWare. Specifically, it's a LightWare SF45B scanning LiDAR, and it rotates about 320 degrees. So it goes left, right, and just keeps scanning back and forth, shooting out a laser beam and detecting objects in its path. So the thought is this will live on top of the drone, above the propellers and GPS and everything, and scan that 320 degree pattern and integrate with ArduPilot so that if it sees an obstacle in its path, it will brake the drone. Much like a fence does, except this will be a little bit more dynamic in detecting objects that it's approaching or that are coming near it. I'll show you how to connect it, how I mount it to the drone, how to configure it in AutoPilot or in ArduPilot, and then we'll have to wait a little bit till the spring to actually try it out and fly it though. It's snowing here, so I really can't get outside. It's too cold, too wet, and so I'm in the basement playing with a bunch of electronics right now. So let's head over and we'll take the box, take the LiDAR. I'll start to show you how to connect the wires and hook things up, and we'll get rolling. All right, let's talk a little bit about the hardware you're going to need for this LiDAR setup. So first of all, the LightWare LiDAR came in this box, right? Little outer shell. Open it up, and it came in this anti-static bag. And at the bottom, there was the wire that interfaces to the LiDAR. I've already pulled everything out, so let me show you what came in the box. So basically, it came with the LiDAR itself and this wire with bare ends, okay? You'll see I have a connector connected to it, but I already soldered that together. And the wire attaches to this little header at the bottom of the LiDAR. Now, there's also a micro USB port on it that you can use to test this LiDAR using the LightWare Studio software on your computer. So you could just take this thing, plug it in to a USB port on your computer, fire up that software, and see what it's scanning. So we'll do that in a second, where I'll show you how to test this thing before we even wire it all up. Now, the other parts you're going to need, so this came in the LightWare box. Get yourself a little micro USB cable so that you can do that test and plug it into your computer. And then the other thing that I'm going to do with this LiDAR is this is a Matek L431 ArduPilot peripheral board, and I used that in a previous video to convert my TF Mini LiDAR to a DroneCAN device, and I'm going to do the same thing here, where I'm going to use this board to convert this LightWare LiDAR to a DroneCAN device. So the LightWare LiDAR speaks serial, or it wants to connect to a serial port. And what this little device will do will let me plug into its serial port on one end, and then on the other side there's a DroneCAN port that will plug into the rest of the DroneCAN hubs that I have in my drone. So that you may or may not want. I've been finding it really helpful to convert all my devices to DroneCAN though, because serial ports are limited, and this gives me a nice kind of standard cabling system throughout the drone to run CAN cables everywhere. Let's talk about the connection as well. So you're going to need, I'm connected at least to a Cube Orange and the core carrier board. And so I followed the ArduPilot website showing you how to wire this, and you're going to need to do the same. To create your cable, these three cables that come with the LiDAR, the green, the blue, and the white, stay unconnected. I'm just going to coil those up and leave those tucked away somewhere in case I want to reuse the cable for something else in the future. The other cables, the red and the black and the yellow and the orange, are your power and serial connection cables. Okay? So I'll give you a close-up of those. Now, what you want to do is you're going to take a JST GH 6-pin connector, and I bought the ones that are on Amazon. They already have pre-crimped wires, and I can just plug them into the connector I want. And I cut the other end, and I soldered it to the connection. I kind of spliced it together to the wires that came with the LiDAR. And then I shrink wrapped, put some heat shrink tubing over everything. So what you're going to connect together, and I'll show you the ArduPilot documentation in a minute here as well. You're going to connect, I had to change the color in here. So red, positive 5 volts, your red cable is on each of these. That goes to the far left pin, pin number 1. Your black is your ground, and that's going to the far right, pin number 6. Now your TX and RX serial connections you got to cross over. So in this LiDAR, the orange cable, I didn't have an orange one that went with my 6-pin connection, so I changed it to blue. So the orange cable on this one goes to the blue, and it's going to pin number 2. I don't remember if it's TX or RX off the top of my head, but that's where that one went. And then the yellow cable goes through, and that goes into pin number 3. Okay, so that's how I wired up this connection, and will let me connect it into my DroneCAN interface. In this Matek board, you'll see it's got a 6-pin header on it. That is the exact same pin out as the serial ports on the Cube Orange and the core carrier board. So you can plug this serial connection right into your core carrier board if you want, or you can put it into one of these Matek devices, but the pin out and the connectors are compatible. So that is going to look like this. So here's what the wiring kind of looks like. Let's go play with it though in LightWare Studio for a second. So I'll unplug it from here. By the way, when you do connect this, right, the other side are your CAN ports. So you can actually daisy chain CAN devices through here, I believe. I'm just going to take a CAN wire and connect it into here, and then go to my CAN hub that's in my drone. So that's the only other part that we'll have to wire up. Okay, so let's go hook this up in LightWare Studio. I'm going to just disconnect it from my Matek ArduPilot peripheral board, and we'll connect to the serial interface, or the USB port, I'm sorry, and plug it into a computer and see what it does. All right, let's hop on over to the computer. Okay, so over here on the computer, I took you to my GitHub page that has the wiki and source code, 3D print files, everything that I did for this drone. The link to this GitHub page is in the description of the video down below. So what I want you to do is click on that, and you come here, and you're going to, below the code section, see kind of the title for my homepage here. And there is a link to access the wiki and documentation home folder. Click that, and you're going to get to this page that has everything kind of organized documentation-wise and in order by video that I produced them. So video 1 is about assembling the frame, video 2 is looking at the electronics, and so forth. We are down here on video 17, the obstacle avoidance and LiDAR. Click on that, you're going to go to a page that has the details on setting up this LightWare S45B LiDAR. Now what I want you to do is scroll to the bottom. I have some references down here. The first thing that I want you to go to is the ArduPilot LightWare SF45B setup page. And I'm going to open that in a new tab and read this. This will give you details about the wiring that I just talked through in that last video. Okay? And it will tell you which wire goes where. So the orange is the RX cable, serial wire, and it will go to the TX connection on the serial port on your cube. Okay, this is the same 6 pins here that we were just walking through in the prior video or prior segment. So read this. Take a look at how it all works down here. Look at the parameters, and then there's a pretty good video here where one of the ArduPilot developers does some really cool stuff. It's a really nice demo where he's showing how the obstacle avoidance is working. As he gets closer to the drone, it backs up. So kind of a fun watch. For right now, though, let's go back to my wiki page, and what I want you to do is get LightWare Studio. So there's a link here at the bottom. I'm going to right click and open that in a new tab. And you're going to go to the LightWare Studio download page, where if you scroll down a little bit, I'm a Windows PC, so I'm going to click the Windows Users Download. I'm going to download that file and install it. I've already done that on this PC, but you're going to want to install it on yours if you haven't yet. Okay. And now that LightWare Studio is installed, if you run it and your LiDAR is connected via the USB port to your computer, it should auto-detect it. So you can see it comes up and shows mine right here, the SF45 on COM18. Now if I click that, it'll take me into a page, and it's starting to scan the LiDAR right now. So kind of a neat little thing going on to be able to test it and make sure it's working. If you go to the upgrade tabs, upgrade external, you can see if you got the latest firmware. So I'm on 1.3.0. And if you go to the scanning tab, it will start to show you what it's scanning. And you can change the angles that your LiDAR rotates through. So let me maximize this so you can see it all, hopefully. So for example, I want it to go left to 160 degrees, and I want it to go all the way right 160 degrees, giving me the full 320 degree coverage. And you can change the speed so it moves slower or faster, and you can have more points logged here. So if I update that to 1,000 points, you can see it's tracking a lot more. All right. And if I change this to, for example, -90, you can see the left-hand side here. It's only going 90 degrees and sweeping to 160 on the other side. So kind of a neat little thing. If you put your hands in front of it, you can see if it's detecting anything and kind of make sure that it's working. All right. Let me capture a little video here to overlay in at what this looks like too. So it's scanning back and forth, and you can see the details getting reflected on the LightWare Studio interface. All right, so let's take a look at integrating this in to the drone. For integrating this into the drone, the first thing you'll need to do offline is solder your connection. I think I went over this in an earlier part of the video, but follow the instructions. Your green, white, and blue cables from the RP or from the LiDAR will not be connected, and your orange, black, yellow, and red cables will be connected. And you're going to connect them to whatever you need to connect to your serial port on your flight controller. In my case, it's a JST-GH 6-pin connector following the serial port layout. So that top one is the +5 volts. The next one, the blue, is connecting to the orange cable from my LiDAR. The yellow connects to the yellow, and the black connects to the black. The black is ground all the way at the bottom. So I did that, and I put a little heat shrink tubing over it just to kind of keep it all together. And I left all the wires there. You can trim it if you need to, but I wanted to leave it long because I might need to put it on something else in the future. All right, so then what I also have here is a new lid that I printed for the drone. It's much, much taller than the old one. The STL file is on my GitHub, so you can download this and print it yourself. It's got the tabs to attach to the top of the RGX hobby frame, some little slots for air to get through, and mounting holes at the top for the LiDAR. It also has a little arrow pointing where the front of the drone should point. Okay, and what I did for mounting this then is I got some M3x8 screws. I bought one of these little screw kits off of Amazon. And so I'm using M3/8, and then I also got some M3 nylon lock nuts. The LiDAR does come with some screws and with some hex nuts. I like to use the locking nuts though on these so that they're a little bit more vibration proof. So what we're going to do is the LiDAR, the front of it is the opposite of where the USB port is. So this is the back, okay? And what I want to do is I want to take a screw and I want to put a washer on it, okay? And we're going to put that through. And each one of these is going to go onto the top of the drone. Actually, the first thing I really want to do is run the cable through. So I'm going to put that cable through the hole that I have right in the middle of this top. Okay, we'll make sure we line it up. There we go. So the serial port is in the back. Now I could take my screws. I'm going to start putting those through. Okay. And while I got the first two screws in, I'm going to go ahead and just attach the nuts to it just to start to hold it. So on the bottom, I'm going to do the same thing. I'm going to put a washer, and then the lock nut's going to go on. And so I'll just start that with my finger. Do the second one and then tighten it down. Not sure how well this new lid will perform. It's big. It's not aerodynamic by any means, but it does have a lot of space, so I mean you could attach other things inside of here and keep them covered if you wanted to. So we'll tighten down this first one. You don't want to go super tight because you'll end up cracking the plastic if you do. Okay. There's two of the screws in there. Now the reason this was so tall too is those arms on the drone actually flare up a little bit. So I needed to have enough height on this LiDAR to get above the GPS mounts and above the props and everything. I just needed a clear line of sight outside all past of the drone. So this was the best way I can come up with for doing that. Try this last one. These screw holes aren't perfect. I mismeasured them a little bit when I printed the top or designed the top in Autodesk Fusion, but they're close enough. You may just have to push it down or screw it through with a little bit of pressure. All right. Get the third nut on. And we'll do the fourth with the washer and a nut again. So that's what it looks like now. LiDAR is on the top. If I get the arrow pointing forward, you can see it moves about 320 degrees to each side, which is good. It's mounted, it's on there pretty solid, and our wires come out onto the inside. So what I think I'm going to do now is we need to mount this Matek L431 DroneCAN adapter, because that's going to connect to the serial port of the LiDAR, and then the DroneCAN connection will go into this. So I think I'm gonna put something in here to hold the wires tight inside, bundle those up nicely, and then I'm probably gonna mount this board somewhere down below so I can easily take the top off and unplug the DroneCAN device. So let me pause there, figure out how I want to do that, and then I'll start recording again. Okay, I went ahead and just mounted it with some Velcro and zip straps inside. So, not sure how well you can see that, but I bundled up the wire and used some zip ties and one of those little sticky things that zip ties attach to, and stuck it to the top of the drone, or of the lid here, and then I put another one here to hold the wire and a zip tie, and then I mounted this L431 board with some Velcro. So it's just double-sided Velcro that sticks to both sides, and then I can take it off if I need to. So that's what the inside is looking like. Not sure if the light helps. So now we can go ahead, when we put this on the drone, plug our DroneCAN wire right into there and stick it on, and we'll screw it on. So let me see if I can get that attached up and show you what it looks like then. Okay, I'll try to see if this shoots well. I have these nice kind of insulated CAN cables that I bought from 3DXR. This is a 24 centimeter one that I bought, and I went ahead, it's hard to see, I did it off camera because you don't want to see me struggling with this, but I plugged it into my CAN hub down inside there. Okay, so with these Holybro CAN hubs, and then actually it's a CAN splitter coming off the hub, I got a ton of DroneCAN ports, which is really nice to be able to add peripherals like this really quickly. So now I want to take this cable and I'm going to run it around, because if you remember, I glued or Velcroed the Matek board to the left hand side of this thing. So I'm going to go ahead and I'm going to run this DroneCAN cable behind these power wires going to my compute board, and I'm just going to kind of tuck it behind everything, I think. There. And now I'm coming up what's the left hand side of the drone. So probably not enough room in the screen here to show, but there's our lid. Okay, and so I want to align it with the arrow pointing forward on it, and what I'm going to do is just go ahead and connect this cable in here. Apologize, this is not going to film well because of the height of the drone and the position of my camera. Anyway, that connects in to the Matek board in here, and then finally we can kind of tuck these cables in, and our lid should sit nicely on top of the drone then. Okay. So let me back this up and see if I can give you a better show of it. So that's what it looks like. All right. And if you remember, there's 4 screws around here that you just go ahead and you screw these down right to the frame. So I won't do all 4 screws and bore you with that, but that's what it looks like. It's going to be scanning at the top. And then I'll go ahead and let's put this on a table so we can kind of flare the arms out and see what it looks like actually scanning. All right, before we can get this proximity sensor to work, we actually have to install the firmware on that Matek L431 board and set up the parameters in ArduPilot. So let's do that first. In the link, in the description of the video, there's a link to this GitHub page. And I want you to click on it, and it should take you here to my GitHub drone page. And I want you to click this button or link for click here to access the wiki and documentation home folder. Go there, scroll down. We're going to go to video 17, the obstacle avoidance LiDAR, and click on that. Now I have the instructions here that you're going to need to go to. And so the first thing, right, your Matek board, here's a link to it. This AP peripheral board, and it'll just show you what it looks like, its specs and stuff. Nothing to do here, but it is a little bit of a good handy reference for the wiring and pinouts. Okay. But what you need to do is this second link here, download the latest firmware, and we need to download the proximity sensor firmware from ArduPilot. So if we open this link, let me open that in a new tab. You're going to get to a page, and you're going to notice it's on AP peripheral, stable, and then the Matek L431 proximity. So the cool thing is they have firmwares for all sorts of different boards and functionality. And you'll notice I just went up a directory, the Matek 431. You can have it for ADS-B, airspeed, battery monitoring, GPS, and so forth, right? But we're in the proximity one. And what you're going to do is you're going to download the AP perif bin file. So if I click that, it should download, and I'll have it here in my downloads folder. Okay. Now, we'll go back to my GitHub page. We're going to need to fire up Mission Planner and connect. Okay, so let me get that going. And I have a USB connection to my cube right now. So I'm going to go ahead and connect via Mavlink. So let's cancel that. Let's go at 115.2 for the baud rate. Okay, so I'm going to maximize Mission Planner so you can see everything in here. Now go to your Setup tab, and under Optional Hardware, there's the DroneCAN, UAVCAN link here. You're going to click on that, and I have my board connected to CAN 2. So in my drone, the GPS and motors are connected to CAN 1, and my battery monitor and the LiDARs and such are connected to CAN 2. So I'll go ahead and connect, and it should show all the devices out here. And you'll see all the DroneCAN devices that you have connected. And you might have to figure out which one is which if you haven't installed the firmware yet. But in my drone here, you can see node 117 is this proximity sensor. If you have not installed the proximity firmware on it yet, it will say something else. So you'll have to find the right one in this list. But then you're going to go to Menu to install the firmware. You're going to go Menu, and you're going to go Update Beta. And it says, do you want to search the internet for an update? No. And it'll ask you to provide a bin file. And what you're going to do is you're going to pick that AP perif file that you downloaded, okay? So I'm going to say open, and it's going to go ahead and talk to that board and load the new firmware into it. And then you might have to restart it, so you can go menu, restart. Okay. Let me hop back to my wiki here. So what you're going to need to do now, we just did these steps here. We uploaded the firmware. Now we're going to have to open the parameters for that L431 node. Okay. So to do that, let me stack these side by side here. On this DroneCAN device, you're going to go menu and parameters, and it looks like, you know, a subset of the ArduPilot parameters on this peripheral board. And what you're going to need to set on these specifically are these values here. So PRX baud rate I set to 115.2. PRX port is 2 for that serial port that we connected to. PRX1 underscore type is going to get set to 8 to tell it it's that LiDAR. PRX1 orient, 0. PRX1 yaw correction, 0. And these angle parameters, I just left as 0 right now as well for the ignore angles. Okay. And when you have that set, you're going to go ahead and write the parameters. And that should have your L431 node talking successfully to the LiDAR. The other thing we need to do is actually tell your ArduPilot, your cube, that it has a DroneCAN proximity sensor. So we're going to go into the config then, and the full parameter list, and we're going to set PRX1 type in here to 14, which means DroneCAN. Okay, and I already have this set. So what we're doing is the ArduPilot thinks it has a DroneCAN proximity sensor, and that L431 board knows that it's the LightWare SF45B connected to its serial port, and what that little board is doing is translating the serial data to DroneCAN messages that your cube can interpret. Now there's a couple other parameters that you might want to set in here. There's some avoid settings. So avoid underscore. So avoid altitude min. The proximity avoidance will start working only once you're above this altitude. You might need that if it's picking up the ground. Avoid behavior. So do you want it to slide or do you want it to stop? And then avoid distance max. Distance from object at which the obstacle avoidance will begin. So that's just the default of 5. Avoid enable. I got that set to the defaults as well. So it'll try and avoid using the proximity sensor or the fence. And then avoid margin, I left as the default as well of 2 meters. So the vehicle is going to attempt to stay at least this distance from objects while in the GPS mode. Okay, and then you're going to take those parameters and write them. And I'm going to hit Control F. You can go ahead and reboot your flight controller. And what should happen when it comes back online is you should see your proximity sensor start to scan. Okay. Now remember, we use the LightWare Studio application to control the degrees, and if you remember, I set that up for the full range of motion, so it goes negative 160 degrees to a positive 160 degrees. So if you look at your drone now, it should be scanning left to right. Now, one thing that you can view is if you, again, Control F and bring up your kind of tool palette here, there's a button in here for proximity. You can click that, and now you can start to see what your drone is seeing. We'll close these buttons here, and you'll start to see where it's picking up objects, okay? So to the right of it, it's seeing something about 2 meters to its right, about 3 meters to its left. Behind it, it's seeing about 4 meters, and in front of it, about 4 meters. Okay? So that's essentially how this works. And you can start to scan and play with your drone and have it pick up objects that it's detecting and either stop itself or try to slide and avoid them. So let me see if I can set up one more little demo where maybe I can show you the screen, and maybe if I can film myself putting objects in front of the rangefinder so you can see that these objects are actually getting detected. So I'll pause there and see if I can set up some sort of way to film that and then capture that for the rest of this video. Okay, so I got my son to help me in measuring these distances, and the top here is the drone itself, or the front of the drone. So about 2.4, 2.1 meters away. Ben, go ahead and walk closer to the drone. Just start walking straight into it. So you can see this thing coming in as he gets closer and it detects him. So now if you back up, Ben, go ahead and hold the tape measure out. Like, go about 24 inches away from the drone. So he'll try and hold the tape measure, and it'll be 24 inches from the top of it, Ben. So it's measuring about 1 meter right now. And put your body about 24 inches away, or put your hand in front. So put your hand right at the 24-inch mark. So there it goes, down to 0.8, 0.7 meters. All right. And then as you pull the tape measure off, you can put it away and then just start backing up. It should start detecting him walking away there. Now, go walk around to the right hand, like come towards me, and get closer to the drone, which should be its left-hand side, right? So as you start getting closer to it, you can see its left-hand side is coming in at 0.9, 0.8 meters. Okay, so now walk away, go back up. And that 45-degree angle shows him walking away. So that's what it's measuring around the drone and seeing. And it would use that to detect the proximity to its objects and try to avoid them. So hopefully this video help you set this up.